Hey there, I'm Joe Weems. Before we get into the video, I want to remind you about ng-conf 2023 happening in Salt Lake City, Utah on June 14th and 15th. Head over to ng-conf.org to check out the speakers, check out the talks, and to get your ticket before they all sell out. We'll see you there.
Welcome to this talk on real-time applications with Angular and NestJS. My name is Ely Lucas, and I am a developer experience engineer at Cypress. And I come from the state right next door, Colorado. You can follow me online at all the socials at Ely Lucas. And so I'm really excited to talk about this stuff today because it's about some of my favorite technologies going on right now. We got Angular, we got NestJS, and we got a really cool way to connect the two together with WebSockets. So let's think about what a typical web application looks like nowadays. Applications are really data heavy and data intensive, and it's kind of critical that if there's new data available that it gets to you right away. So for instance, we might have a new message notification come in that needs your attention. Or somebody might be having a live one-on-one chat with some type of support representative, and it's critical that those messages go back right away. Or you might be looking at some type of chart to try to make an important decision for your business. And if that chart data changes, you want to make sure that you're having the most up-to-date information. You want to see that chart change in real time so you're making the best decision you absolutely can. Now, the problem with this is that traditionally, the way that we talk with our servers through HTTP wasn't initially meant to do this. HTTP was more of a client request, server response model. And so if anything ever happened on the server side, you'd kind of have to wait for the client to request the new data. However, we're pretty ingenious people, us developers, and we came up with some ways to get around this. The first of which was HTTP polling. And this is where you're setting up some type of interval in your JavaScript code to make AJAX requests back to your backend server. So let's say we're checking like every 30 seconds, right? You could be like, hey server, do you have anything for me? And the server is like, hey, yeah, I do. Here's a new message notification for you. 30 seconds later, hey server, do you have anything for me? Yes, I do. Here's a new chat message that just came in. Now, the problem with this is that it's not really real time. The data that you're seeing is only as fresh as the last interval, and that kind of defeats the purpose of some of this stuff. The other problem is that this is often resource intensive. You're making these requests every 30 seconds, whether there's new data available for you or not, and a lot of those requests could just be wasteful. So to kind of get around some of those limitations, we have HTTP long polling. And this is where a client opens up a request to the server, and the server's going to hold on to the request, and it's going to hold on to it until it actually gets data to hand back to the client. And so, hey, new data has come in, the server's going to send a response out that already open connection back to the client's going to receive it, and then immediately open up a new request to be held. Now, the advantage that this has is that the data is actually more real time. You're getting the data as soon as it's available. However, it still has the resource limitations on your server that the other one have. In this case, you're keeping all these HTTP connections open against the server, which are fairly expensive to maintain. Also with this method, the client can't send additional messages over that same connection. It has to open up a new request to do so. Then we also have server sent events, and this one was actually a pretty good solution to the problem. Our server sent events are kind of like long polling. We're going to open up a request to the server is going to maintain that connection, and then when there's new data available, it's going to send it back out to the client. However, the client's not going to close the connection. We're going to use streaming technology to send any type of other new data come in as an additional response. And so the advantages of this is that we have one maintained connection. We're not having to reestablish connections over and over again. The disadvantages are still the client can still not talk to the server, and we still have all these network requests open to the server as well. And if you think about how this scales, if you have like dozens or hundreds or even thousands of clients all doing these types of technologies, you're going to run into a scalability issue right away with your servers. But fortunately, we have a solution, and that is WebSockets. And WebSockets really aren't anything new. They've been around for a little over 10 years now, and they're pretty ubiquitous. And you can use them in pretty much any modern browser and any server framework. And what a WebSocket is it's just a thin layer built over TCP that can send light messages back and forth between the server. And this connection is persistent, so it's already connected when you need to go send the message. And this is what it looks like when you need to make a WebSocket connection. So you have your client and you have your server. The server is going to talk to the server through a regular HTTP request. And it's going to say, hey, server, I want to talk WebSockets. Do you talk WebSockets? And the server is going to be like, heck yeah, I talk WebSockets. Let's do this. Here's a little bit of information that you're going to need to do so. And then the client's going to be like, okay, and it's going to open up the WebSocket connection. And from here on, you have a persistent TCP connection opened up to the server. What are the advantages that you get here? Well, for one, this channel is bidirectional. And that means both the client and the server can send messages to each other. The channel is also full duplex, which means the client and the server can send messages at the same time. Then this opens up many possibilities to do event-based driven architecture, where when new events happen on either side of the equation, they can send events to notify the other side. Since there's only one persistent connection open, you don't have to worry about the latency that it takes up to set up a new HTTP connection for every single request. And so if you need to do something that needs to get back and forth really quickly, like maybe some like gaming or stock updates or anything like that, the milliseconds or the second or so that it takes to establish a brand new connection and do SSL and all that fun stuff isn't there. Also, since we're sending just the messages back and forth across the wire, we don't have to worry about all the headers that go along with HTTP requests. None of that's there, so the data packets are much smaller. However, WebSockets don't replace HTTP. In fact, you're still going to be doing most of the communication that you do now to your server via HTTP. Let's talk about some of those use cases. So first and foremost, when you need to serve up web pages, you're not going to be serving up web pages or documents or images or anything like that via WebSockets. You still have to make that initial connection, request that initial document through HTTP. Also, WebSockets do not replace your traditional HTTP APIs that you're currently creating through like REST or GraphQL or something like that. If you have those are usually better use cases for CRUD type scenarios. Especially when the data that you're requesting doesn't change that often. And so a good use case might be if you're looking up yesterday's sports score. Yesterday's sports score isn't going to change. And so you don't need to worry about it getting updates for it in real time. However, if you're looking at a game that's happening real time and you want to get like the latest scores and the latest stats and stuff like that, that makes a really good candidate for a WebSocket connection. Also, if you need to cache the data, you're going to want to be using HTTP, which pretty much has all the caching stuff built into it. WebSockets does not. Same goes for error handling. Error handling now with HTTP is pretty ubiquitous. Developers pretty much know what to do when certain status codes come in and events happen and whatnot. WebSockets doesn't have any of those type of standards built around it. So if you're going to do error handling in your WebSockets, you're pretty much going to have to build that yourself. So now that we know all about WebSockets and the use cases for them, let's talk about some of the tools that we can utilize to build these types of applications. So first and foremost is Socket.io. And Socket.io is kind of like the de facto real-time library in the web world. And so it is a client and a server library, so there's libraries for both sides for real-time communication. It uses WebSockets, and it has a fallback to long polling. So if for some reason a connection cannot be established via WebSocket, maybe there's a firewall in the way, or maybe the browser doesn't support WebSockets or something like that, it's going to fall back to long polling, so your application's still going to work. And a lot of people wonder, it's like, well, why do I need to use Socket.io? Why can't I use the WebSocket API directly built into the browsers? And it's because Socket.io does a lot of the boilerplate code that you're going to need to do on your own if you didn't use it. And so a good instance of this is Socket.io has built-in reconnections. And so if for some reason your client drops its connection, maybe you're on spotty Wi-Fi or on your mobile phone, you drove through a tunnel, like Socket.io is going to automatically reestablish the WebSocket connection on your behalf. Also, it has a small client footprint, so it doesn't add a lot of overhead into your Angular apps. It's 10.4 kilobits minified and gzipped. And next, on the server side, we have one of my favorite technologies. I've been a big fan of this for years, NestJS. NestJS is a node-based web framework. And usually when you think of node frameworks, you kind of think of Express. Well, NestJS actually uses Express under the hood, but the differences between the two, especially for us Angular developers, is that the architecture of NestJS is heavily influenced by Angular. So you get a lot of the same things on the server side that you're used to having on the client side, stuff like modules and filters and pipes and interceptors. You have a CLI that can generate and scaffold code out for you. And the nice thing about this is that if you already know NestJS and you're hopping onto another NestJS application, you kind of already know how to get around in it. Also, NestJS is powered by TypeScript, and you get a lot of the same features in NestJS that you do in Angular, like it powers the dependency injection, and it makes heavy use of decorators and aspect-oriented programming and heavy use of generics. And so it's a really great language to use on the server side. Also, NestJS just isn't a web framework. It's kind of an entire platform. You can use it to build REST APIs, GraphQL APIs. As we're seeing today, we're going to build a Realtime API, but it could also do back-end server-to-server communication. Pretty much like any type of server-side app that you want to build on Node, you can use Nest to do so. Also, this might just be the 90s kid in me that grew up watching Thundercats on Saturday morning, but I happen to think NestJS has one of the best logos in all of open source. All right, now we got Angular, and that is why we're all here. How do we use these technologies inside of our Angular apps? The first thing that we're going to do is we're going to use the Socket.io client library directly in our application. Now, there are other libraries that wrap Socket.io and make it more friendly to Angular. And those are great, but I'm going to show you today how to use Socket.io inside of a service and kind of like abstract all that logic inside of a service for you. And kind of some of the same things that those libraries would do, but it's important to know what's going on behind the scenes. And a lot of the times with data, we wonder about how are we going to persist the state of this data. And today I'm going to show you why I think behavior subjects are a great use case for real-time data. Behavior subjects will keep your connection open or keep your observable open for you. Where a lot of times with HTTP requests, the observer is going to close as soon as the connection is done. Real-time data, that data can come in anytime. You don't want that observable closing. So we can use a behavioral subject. As soon as somebody subscribes to it, we'll get the latest value. And anytime a new value comes in, we'll get the new values. Okay, so originally this talk was built as a hands-on workshop, but then the rooms got shifted to this room, and this room's not very conducive for pulling out your laptops and coding along and all that kind of fun stuff. However, the workshop is still prepared, and so if you want to take this deeper, go through it all yourself, I really encourage you to get the workshop. It's at bit.ly/ng-rt for Angular/realtime. I will have a link to this at the end too, so don't worry if you don't get snapped yet. But yeah, the workshop walks you through building a multi-user, multi-room real-time chat app. And so instead of like doing that as the workshop, I'm going to do it live on stage. But first, a little bit of knowledge that we're going to need. And here we got Socket.io connections. The important thing to know here is that in Socket.io, each connection gets a unique client ID. And every time you reconnect, you get another client ID. And so there's this process that you go through. I like to call it identification. And it's where you associate a client ID with a user in your system. And this is important because if you want to send a message to that particular user, you're going to need to know their client ID to do so. Next, we got the lifecycle methods. And the two that we're going to be dealing with today are connect and disconnect. And these are called on your behalf by Socket.io on both the client and the server when either clients connect or disconnect. Now some nomenclature inside of Socket.io. We have two primary objects that we work with. The first of which, they're kind of called socket/client interchangeably. But when we're using a socket or client, this is when we're actually dealing with the particular client that is sending messages back and forth. On the client side, we only have clients. On the server side, we have clients, and then we also have server objects. And so the server object could be used to interact with any other client, not necessarily the one that's currently sending you messages. Then we also have connection namespaces. And namespaces are kind of like paths in a URL for a REST API. They allow us to group our logic into like a single class and have multiple ones, so not all of our WebSocket code is in the same class for it. On Nest, the Nest side, we have gateways. And so if you used Nest before, you see that they build these abstractions around Express to be able to create REST APIs. Gateways are kind of the same thing. They're the abstraction around WebSockets and Socket.io. They're analogous to controllers and REST APIs. And so a gateway is going to be responsible for all the communication that happens from your client to the rest of your backend, and then unlike a regular controller, a gateway can also just push messages to the clients as well. We use decorators heavily inside of a gateway, and I'll show you how all that works, and it kind of ties the Socket.io library to our particular classes. All right, now let's dive in and do some code. Okay, so here is the code that you will get if you download the repo. It's kind of a mono repo. We got a client folder, which maintains the client Angular app, and then we have the server folder, which is the Nest app. I'm going to use a couple of generators here to get us started. And I'm going to start all the way in the back end of the application and build it all the way to the front for each step that we go through. So it's going to be a little bit of coding before we actually see anything happen on the client side, but I think this is probably the best way to explain how all the data flows to the application. So I'm going to the server. Oh, let's get into the right directory. Go into the server, and we'll run nestg for generate. We're going to generate a new gateway, and we're going to call it chat. And going to do nestg service. We're going to do a service as well, and services in Nest are very similar to services in Angular chat. And then I'm going to go up into the Angular app, and I'm going to create a new service for Angular. And this is going to be all the generation that we need to do. And from here, I'm going to run npm run start. And the start script is modified slightly, so it's going to start up both the Nest server and the Angular server at the same time. And if I come over here and give this a refresh, you can see it is up and running. So this is the initial screen. This is kind of the login screen. It's not doing anything yet because we haven't added any interactivity, but the idea is we're going to enter our name, we're going to hit connect, and we're going to go into the chat room. All right, so I am going to minimize this, and I have this little extension here that holds all these code snippets so you don't have to see me do a lot of live coding, thank goodness. Okay, I'm going to go into the chat service on the server side. And so this is a chat service. It probably looks very familiar to you as Angular developers. The same concepts apply here. We give it the injectable attribute, which means that this service can be injected into other parts of the application via providers. I'm going to get rid of that and paste in a new one. And so our service is mainly going to be concerned with the state, the data persistence of our application. And we're storing everything in memory in this particular app, but you could like modify this source to store everything in a database. And to store everything in memory, I'm going to use a map. I'm going to call it users. We're going to use the record type, and it's going to have a key of a string and a value of a string. And the key in this case is going to be the username, and the value is going to be the client ID. And we're going to associate those two together here in this identify method. So we're passing the user, passing the client ID, and then just map it over to the user's object. And disconnect is going to do something very similar. However, we don't get the username in the disconnect. We only get the client ID. So we kind of have to take the user's map, get its keys, search for the user, find the particular one, and then remove it. Okay, over in the gateway, and this is what a gateway looks like. You can see that we're using decorators here. And so we have a plain JavaScript class, and we use the WebSocket gateway decorator to tell Nest, this is a class that's going to listen and respond to WebSocket connections as they come in. And in here, we can pass in an options object. And this options object ultimately gets passed down into socket.io. First thing that we're going to want to do is enable cores, because WebSockets follow all the same rules around cores that regular HTTP connections do. I'm going to enable it for everything in here, but you can actually get really granular with your list of cores rules. And then the second thing we're going to do is we're going to set up the namespace to be chat. So any messages that are sent to the chat namespace, this is the gateway that's going to be responsible for communicating with it. And right here, this is how we subscribe to new messages coming in. Socket.io and WebSockets in general is kind of a pub/sub type system. We're going to publish a message with a particular name, and we're going to listen for those messages on the other end. And so this is how we listen. We're going to subscribe, and we pass in the key to the event name that we want to subscribe to, and then this is the method. The first parameter that comes back is the actual Socket.io client that I told you about. So this is how we could communicate with the directly connected client. And then the payload is anything that was in the actual message body for the WebSocket. I'm going to go ahead and get rid of this one that's in here and add some new ones. Well, first I'm going to put in a constructor so we can import our chat service. And we're going to add a couple of these listeners for the identify method that we're going to call. So this is what I was talking about. We're going to call this after a client connects, and it's going to pass in the client ID, and we're going to associate it with the user inside of the chat service. And then we got disconnect, and this is one of those methods that the client doesn't need to raise by themselves. This is a lifecycle method, so this is going to be called on our behalf anytime the client disconnects. And what we're going to do here is make sure that we go into that user's map and remove the user. Need to import the socket type here from socket.io. Okay. Now on the Angular side, here's our chat service, and then on the Angular side, the chat service is going to be responsible for maintaining the WebSocket connection and any data state that needs to be stored for the client-side portion of the app. So here we got it, and let's talk about a little bit what we're going to want to do. So we have this interface here called chat app data, and this is going to store all the data that's going to get returned back into the application component. We're only going to use the app component in this. I'm not making like a multi-page app or anything, so everything's going to be happening inside the app component. But for right now, we're going to main state for if the user is currently connected to the chat room or not, and the user's name. And to store that information, here we're using the behavioral subjects. And so we'll give them a default value of false and a blank string for user. Now, one thing that we could do is we could expose all these observables, and we're going to have a lot of them, and the app component can subscribe to each one of them individually, or you can get a little creative with how you're going to do that. But I'm just going to expose all those observables as one observable. I'm going to use combine latest to do so. And so combine latest is going to take this array of all these other observables, and anytime one of these updates, it's going to update the main observable that comes out of it. So we only need to subscribe to one observable inside the app component. Now I'm going to create a couple of new members, one to hold the URL for the URL of the WebSocket client or server that we're going to connect to. You can see here at the end we're doing /chat. This is how we specify the namespace. So this is going to connect to our chat gateway inside of the Nest app. In a real application, you're not going to want to hard code this. You're going to use like environment variables or something like that. And then we're going to have the client or the socket. So we'll import this from socket.io. And inside of the constructor, this is kind of where some of the magic is going to happen in regards to actually talking to socket.io and whatnot. So to create a new client, you use this IO object. Now I'll import that real quick. And you pass it in the URL, which we have defined up above, and then the options object. I'm going to specify auto connect as false here, because if you don't, it will automatically create the WebSocket connection. But I want to wait until I actually have the user's name and they physically click the connect button before I make the connection. And this is how you listen to messages using socket.io. So we're subscribing to a message or an event here called connect. This is the one that's called on your behalf. And so this isn't actually emitted by the server. This is going to happen whenever a connection happens. And when we do so, we're going to want to call that identify method so we can tie the user and the client ID together on the server side. And then we're going to set the connected observable to true. On disconnect, we're going to set the observable to false. And then we're also going to store the username inside of local storage. That way, if the page ever refreshes or they come back later, it's already going to have their username. If we find their username, we're going to pull it out, and we're just going to automatically connect them. We're going to bypass the login screen. Okay, I'm going to add a couple of methods here. Now here I got two methods called disconnect and connect. Don't confuse these methods with those lifecycle methods. These are methods that we're going to expose to the app component that will be called via events that happen from the user interacting with the template. And so on connect, we pass in the user. If we're already connected, we're not going to do anything. We're going to set the local storage item, we're going to set the user, and then we're going to call the connect method on the socket.io client, which is going to fire off that connected event. Disconnect, we're just reversing the process, removing the local storage item, disconnecting, and setting the username to blank. And so this disconnect method is an intentional call from the user. This is only going to happen like when they actually hit that disconnect button inside of the chat interface. Okay, now let's move over to the app component. So we got a little bit of default stuff here. Inside of the application, like the template is pretty much already filled out for you. The CSS is pretty much already there. We don't want to spend a whole lot of time on that. And so to make sure that that all ties together, we have some methods here that are bound to elements inside of the template so it doesn't error. And so we have a couple of blank methods here. And let's go ahead and add an observable that's going to contain that chat app data that's going to come from the service. Add these imports. And let's get access to the constructor, or access to the service. We'll inject it into the constructor. And I'm going to replace these three methods here with these. And so when we initialize, we're going to go into the service and we're going to get the chat data observable back. When we connect, if we have a user, so they actually filled out the form, we're going to call connect on the service and then disconnect, kind of the same deal. All right, now inside of the template, this is the chat interface. Up here, I have some hard-coded values. Actually, that did not pull up the right file. That was some cached one somewhere. That was weird. Sorry. So this is what we have. So we have some hard-coded values right now because we haven't added any of the functionality. We have this ng container with a hard-coded if this is where we're going to subscribe to the observable using the async pipe, and then we're going to alias it to data. So all those members that are on that chat app data interface are now available to us via this data member. And then also this div tag we're going to replace, and this is what controls if the login screen is shown or not. And so if we're connected, we're going to show the chat interface, else we're going to show the login. And with that, we should have a somewhat working app. And so I'll come in here and I'll log in, make this a little bit bigger, hit connect, and you can see that we're now connected into the chat room. One other thing that we can do in here now is instead of saying like welcome user that's hard-coded, we actually know the username now. And so I'll say data.user. And there we go. It actually shows the real name. I can disconnect, and I can connect as somebody else, and so on and so on. Okay. Let's talk a little bit about the next step of the application, and that is the ability for users to be able to join rooms and switch rooms from within inside of the app. And for that, Socket.io actually provides a great mechanism to do so, and it's also called rooms. And so I'm going to say rooms about 100 times in the next 30 seconds, so I apologize. But anyways, a room is a channel that clients can join or leave. You can only do this on the server side. Clients on the client side don't join rooms. You join rooms on the server side. And then a message sent to a room only goes to the users who are actually in that room. And so you can specify, you can say client.to, specify the room, and then emit a new event, and that event is only going to go to those clients. So it fits perfectly with what we want to do with the chat room. And this is what it looks like with straight up Socket.io code. So to join a room, you say socket.join, and then you give it the name of the room that you want to join. To send a message to the room, you either use the socket or the client or the server object, and you say to, give it the room name, and then emit the new event. And then to leave a room, you say socket.leave. So we'll start back all the way back in the chat service in the Nest application. And up here at the top, I'm going to add in a couple of interfaces to kind of shape our data. So we're going to have a message, and the message is going to be the user and the content of the message. And then we're going to have a chat room object, and the chat room is going to be the list of users who are currently in the chat room and the messages for that chat room. And then we will actually have a variable that implements the chat room as a record. And we're just going to have a few hard-coded channels in this case. We could add more, but for our demo app, we're just hard-coding them. So we'll have a general channel, an Angular channel, and a NestJS channel. So down here, I'm going to paste in a couple of methods to join the rooms and to leave the rooms. And this is just manipulating that chat room's map. So it's finding the current room that we pass in, and we're pushing a new user to the array, so this user has joined the room. We're also going to sort the users alphabetically after the end of each one, so the list looks nice when it's returned to the client. And then leaving the room, we're just going into the room, and then we're filtering out all the users except for the current one that's leaving. And we're going to also need a couple of methods to get a particular chat room based on its name, and to get all the list of chat rooms so we can populate it inside of the UI. Now, up here on disconnect, we want to make sure that when a user disconnects, that we remove them from the room and then we notify the client. And so up here, I'm going to add a little bit of code that's going to remove any users remove the disconnected user from any rooms that it's currently in. Okay, on to implementing the portions of the gateway. So in the gateway, up here in the identify method, identify is a good place to return back any data that your client might need to load up any like initial data, right? And so we're going to return back the list of rooms. not that one, this one. And so this is going to surface itself as a callback. When you emit this identify event on the client, you can pass in a third parameter that's a callback. Any data that you return from these methods gets into the callback. Okay, we're going to add a couple of new subscriptions here. So we're going to listen to a join room event that's going to get emitted from the client, and also a leave room. And here, this is where we're going. So first thing that we're going to do is we're going to call into the chat service, pass in the room, pass in the user, so that data is persisted. And then we're going to call that client.join. So this is joining a socket IO context of a room. And then we're going to emit to all the clients. We're going to pass in that room, and we're going to say, hey, this user joined. And so the client will get an event that says user joined, and then they can update the users list for their chat room. Same thing, but the opposite for leave room. Up here in handle disconnect, we want to make sure that when a user disconnects, that we're broadcasting to all the clients that that user is no longer there. Okay, on the Angular side, a couple of new methods, a couple of new interfaces. So this is the same message and chat room interfaces. I'm doing some code duplication here. I'm sorry, this isn't wired up with NX at the moment. But so we got the message, we got the chat room. And then we're going to add a bunch of new values to chat app data here. So I'll go ahead and just replace it. So we're gonna, in addition to the two that were already there, we're gonna be keeping track of the active room, the chat room, as well as the list of any users. And we need to add new behavioral subjects for that. So we'll initialize the active room to general. So when they first join, they'll join the general channel. Chat room will get just blank arrays for users and messages, and rooms will get a blank array that will be ultimately be the list of rooms. And now that we're exposing new data, we need to update get chat app data that combines all those observables into one. And up here on the identifier, remember we returned the list of rooms when we identified that initial data that we need. This is how you get that data on the client side. So we're emitting the identify event, and then this third parameter is the callback, and the value that gets passed into the method is the rooms. And so we'll update the rooms observable with those. And then we'll add new listeners or subscribe to these events for user joined and user left. And so this is going to let us know that users joined or users left the room, so we can update the users list. And then we'll add join room and leave room, and these will be called from the app component directly to fire off all those events. When we connect, this is especially important, like at the browser refreshes or something like that, we want to join the room after connection, because if the browser refreshes, that WebSocket connection goes away. All the stuff that happens on the server side because of the disconnect event gets fired. We remove all the users, and so all that data is pretty much lost. So if they reconnect, we want to establish all that again and rejoin them to the room. And then the same thing on disconnect, we want to leave a room when the client disconnects. Okay, and the app components, we'll add a method called switch room, and this will be called whenever you click on a new room inside of the interface to actually go around those rooms. The template, we're getting close to seeing some magic happen. We have some hard-coded list of rooms. Go ahead and replace this with the dynamic list. And so we're going to loop through all the rooms that we have in that rooms array. If we're in the currently active room, we're going to add an active class so we can display it differently to indicate that that's the current room that you're in. And we now have a real list of users, and so we can update that real list of users as well. And we actually know what room you're in, so we don't have to hard code that room name anymore. We can say you are in the active room. Okay, and with all that in place, if I come back over here, there we go. So you can see I got rooms listed. I got general, Angular, and NestJS. I can go back and forth in between the rooms. However, I am in here all by myself, and it is a little bit lonely, and so I have a couple of other browsers over here. Let's get these up and displaying nicely. Let's have Jordan connect, and let's have Adam connect. And make that a little bit bigger so we can see it. So you can see when the other two, or when everybody else joined, the users updated, and as somebody goes around into the other rooms, the list is updating along with it. And you might be able to see this if I hit disconnect here. You'll see Jordan left, and Jordan will come back. Okay. So now we have a chat app, but our chat app can't actually send any chat messages, and that is not much of a chat app. So let's go ahead and do that real quick. And fortunately, most of the infrastructure is already in place, so actually appending these messages is going to be fairly quick. We'll start back in the chat service on the server. And for here, we're just going to need one new method called add message. And so this is going to take the room to add the message to, going to take the new message. It's going to find that room off of the chat room map that we have here, and it's going to push the new message onto its stack. In the gateway, we're going to listen to another event called message to server. And let me import this real quick. And so when you're dealing with event names, sometimes it could get pretty confusing because a lot of them are going to be named similarly. So when you have a direction going on a particular event, I like to mark where that direction is. So here we're saying, hey, this is a message coming to the server. And that's what we're subscribing to. Because we're also going to emit messages to the client. You could call these both message, and Socket.io would be fine with that, but it gets like really confusing as a developer trying to see like, oh, where am I at? And so we're listening to a message to server event. We're calling that add message, and then what we're doing here is this: we're sending the message to everybody else in the room. Now, when you use the client socket object and you call .to and you're specifying a room, it's going to send it to everybody in that room except for the currently connected client. Therefore, we also want to emit it directly back to our client as well, using the same mechanism so the data all flows into the app the same way. So we're going to emit the message twice, once to everybody else, once back to the client who just sent us the message. Okay, on the Angular service side, we need the method to, we need the subscription. So this is listening for those message to clients. When somebody else sends a message, goes to the server sends it back out to everybody else. We're going to push that new message into the chat room that we're in. And then down here, we'll have a method to send a message from the client. And so this is where we send it to the server. So message to server, and then pass in the new message. In the app component, we'll replace this blank method with this one. So we'll say, hey, if somebody actually typed in a message into the box, we're going to call the chat service and send the message. And then the last thing that we need to do here is instead of this hard-coded list of messages, where's it at right here? We're going to replace this div with the dynamic list that's coming through. And so we're going to check the messages length. If there's no messages in the chat room, we're going to go over to no messages, and we're going to say, hey, sorry, this room doesn't have any messages right now. If it's greater than 0, then we're going to loop through all these messages, and we're going to say like who the user was that sent it, and then the contents of the message. And let's come over here and let it go. And so we'll say, hey, everyone. And there we go. We got the message appeared over here, but now let's hop over to these clients, and you can see that they appeared over here as well. And so Jordan's going to be like, hi, Eli. And we're going to see it pop in, and then Adam's going to come over here to the Angular room and say like, I love Angular. And as we go through the rooms, you can see each of the rooms has their own messages. Awesome. So that was the lab. And I kind of hope what I showed you here today, that building WebSocket applications really isn't that hard, especially when you're using a great technology like NestJS and like Socket.io. And it's pretty easy to integrate into your client applications as well. So once again, you can find the code for the workshop at this URL. And just a couple of resources. I know you're all pretty good at like Googling stuff and whatnot, so I didn't want to put a bunch of like links up here. But both the nestjs.com and Socket.io websites, they have excellent documentation. And so make sure like you go through and you read through those as you're working on implementing these apps. And yeah, if you have any questions about any of this, if you're going through the lab, feel free to hit me up on Twitter. Tomorrow afternoon during the speaker meet and greet, I'll be at a table. You can come talk to me about NestJS. You can come talk to me about Cypress. I'll be there. I'll be happy to answer any questions you have, or if you just happen to see me out here, feel free to go. But thank you very much for coming. Have a great rest of your day, and go ng-conf.